Okay, we were discussing the nuclear electrophiles the other day. Now we'll continue the discussion on electrophiles. We were talking about yeah, generation of nitronium ion, which is an electrophile used, formation of nitronium ion. Today we will take up how sulfur trioxide is generated in a sulfonation reaction. Okay, sulfur trioxide is an electrophile. Sulfur trioxide, see the structure. It's a neutral molecule. Now see why it is acting as an electrophile. Why it is acting as an electrophile. I have told you electrophile is electron deficient species. Electron deficient. Electrophile is electron deficient. Now see here, we have sulfur and oxygen. This is sulfur is in the third period and oxygen is in the second period, right? If you take the periodic table, this is your periodic table. This is your first period, number 1 and number 2, second period. Now here, you have somewhere here, oxygen and sulfur. Now look at the electronegativities. The periodic trend of electronegativities, electronegativity increases towards the right hand side. Increase. Electronegativity increases on the right hand side and down it decreases. Electronegativity decreases down. So you can see oxygen is more electronegative than sulfur. And therefore, these bonds you can write delta negative here, delta negative here, and delta negative here. All these paired electrons, the bond, double bonded electrons are attracted towards the oxygen. Now, once that happens, the cumulative effect of this will be delta, delta, delta plus on the sulfur. So the sulfur is highly electron deficient, and that is the reason why this acts as a good electrophile. Okay, now for a sulfonation reaction, what we do is, say we do want to do a sulfonation. What we do is we take the aromatic compound and react with concentrated sulfuric acid. Concentrated sulfuric acid. Now earlier we have seen how nitronium ion is getting formed. Nitronium ion is getting formed by the reaction between two sulfuric acid, one sulfuric acid and one nitric acid molecule here. Similarly, let us see how a sulfur trioxide is getting formed during a sulfonation. Remember, sulfur trioxide can be also made, manufactured. But here, you can use sulfuric acid to generate sulfur trioxide as the electrophile in the reaction mixture itself. And here is your sulfuric acid. Look here. I want you to know the exact mechanism of formation of this. Okay, now here is one molecule of sulfuric acid and here is the second molecule. This is the second molecule of sulfuric acid. And you can draw. Yeah. Now this will act as an acid, this will act as a base. That is how you have to understand it. This will act as an acid. What's the meaning of acting as an acid? What's the meaning? Donates a proton. A proton. What is proton? H plus. Now see how it is donating a proton. You have lone pair of electrons here. You can use this electron or this electron. Practically it makes no difference. Let me use this one. I form a bond of this oxygen with this hydrogen. What happens? You get a OH bond formed. But remember, the hydrogen cannot have two bonds. So naturally, these two electrons will go this side. See the way I have written this arrow. Always remember, arrow will only move from one side to the other. Arrows will never converge into one point. This is right, wrong. This is right. Also, arrows will never diverge from one point. Keep this art. See that. So what is happening is you are forming a bond here and you are breaking this bond. Heterolytic bond fission. Heterolytic bond fission. Okay. Now what do you get? See the result. I will write this completely as HSO3. This HSO3 O minus to make it shorter. Then let me write this part very clearly. HOH here. Okay, remember you have oxygen with two lone pair of electrons. You have two lone pairs of electrons. So I have got sulfur, a double bonded oxygen, again a double bonded oxygen with OH. And I have used up these two electrons here. These two electrons I have used up. So that means I get a positive charge. Clear? So I get a positive charge here. Now see, you got an oxygen with three bonds and a positive charge and a lone pair of electrons. Okay. Now, once you have this, see how it is got the positive charge? By leaving a pair of electrons. The lone pair is donated to this proton to form this bond. So it will have the tendency of taking it back. So see here, it has got a tendency to take it back. And what's the result? This will form water. Water is a very stable molecule. So it is always have the tendency of forming stable molecules. Now what is the driving force of this? If this bond is getting broken, sulfur will lose a bond. Okay, sulfur will lose a bond and sulfur will always have the tendency to get that bond back. And see here, a shift occurs from here to here. Again, see the way the arrow is put. Arrows converge to one side. See here, this arrow from here to here and coupled with this arrow. Same, see that. This is what you have to observe. Arrows will not converge, they will diverge from one side to, and they will not diverge also. They will just go like a frog jumping. Remember that. This is how I can put it. Okay. Now, what's the result of this? Yeah, you take your time and write it. The result of this structure, arrow pushing. Yeah, take time and write it. See, you have a pair of electrons here. This electron is getting converted. This bond pair, this is a bond pair. This bond pair is converted into a lone pair because oxygen has lost a lone pair. So it is gaining it back. And here the bond pair is getting shifted to another bond pair, that's all. What is the result? Write fast. Take your time and write it. Write something. If you don't write yourself and if you are simply blinking at this board, that will never serve a purpose. So write it down. Yeah. You follow only the arrow. That's enough. Now let me write the same thing here in the same fashion. I got O, H, H, and C. This lone pair of electrons is there. Now, what is the result of this arrow? These two electrons come here. Finished. Now, I write as S. No change on this side. No change on this side. And this bond is broken. But you have formed an extra bond here. And that's a pi bond. Plus, see here. What is gone from here? The pair of electrons has gone to the other side. And what happens? Your hydrogen gets a positive charge. Don't forget this positive charge. Now, who will take up this? See here. This will take this and will form sulfuric acid, H2SO4. So H2SO4 is acting only as a catalyst here in this formation of sulfur trioxide. So this is the formation of another electrophile. And see, we are going to use this in our aromatic reactions. At that time, I will not teach you. I will ask you how to make this by yourself. Okay, so this is another electrophile. Sulfur trioxide is a neutral electrophile. Don't forget it. It's a neutral electrophile. And see here, did we see how Cl plus is formed? I think yes. Is it not? CH3 plus we have seen. Yeah, Cl plus also we have seen. Yes, both we have seen. Okay, now one more electrophile is CH3CO, acylium ion. Acylium ion. Acylium ion. How do you form acylium ion? Acylium ion is CH3CO plus. Now this plus charge you can put either on the carbon or on the oxygen. We'll see how we can do that. Now this CH3, you can write either CH3 or you can write RCO plus. Now, how will you form? Can you guess from what this compound can be formed? Can you guess? Yeah? The easiest way is you can prepare this from RCOCl. This is because you cannot break this bond. You can break easily this bond, but you cannot form this from RC double bond OH. You cannot break this bond so easily as you can break this bond. That's the reason why, see, CH3CO, you can prepare only from here, from RCOCl, not from carboxylic acid. Okay, now you convert this R C double bond O. Now see how this breaks. This is breaking this way. Okay, it is breaking this way. RCO plus. And now see here, you have two lone pair of electrons here. And you can write a resonance structure. This is what is called resonance structure, which we are going to learn later. Don't worry. See here. What I'm doing is I'm converting this oxygen, this lone pair of electron into a bond pair to neutralize this charge on this side and make this positive. So this is what is called a cerium ion. Okay. Now, how? No, this will not occur on its own. This will occur only in presence of AlCl3, which we have already seen. Why? Because R C double bond O Cl. This bond, the Cl is taken by AlCl3, which is electron deficient, as I have already told you. Cl, Cl, Cl. And you get R C double bond O plus AlCl4 minus. Okay, and this is what is called helium ion. So formation of helium ion is, you can use a Lewis acid for that. This is called a Lewis acid. Okay, right. Okay, so that is our discussion about electrophiles. Next, we'll take up nucleophile in detail and see how that is getting formed. Okay, thank you.